I'm David Pepper with Abaco Systems. A couple of things occurred to me as I was getting up here. One, I believe, and I'm fairly certain of this is my first public presentation as an Abaco Systems employee, and I also believe that I'm potentially standing in the way of lunch, so I'll try to get this done pretty quickly. But I'm going to be talking just real briefly about how you could address a radar processing need with the 3U system. We've heard a lot about swap, especially this morning, so it's a big problem, and again, I would agree very heartily with what Ivan said earlier. I mean, 3U seems to be a very, I wouldn't say ubiquitous, but very popular platform for addressing the needs when you have a swap challenge. So this is the kind of thing that happens really, and this is a trend, so we're talking about embedded tech trends. So if you think about it over time, we've really worked hard to get the processing into the platform, and that's really in the middle there. You're really trying to have the classic system might have been, uplink, downlink data, do a lot of back-end processing on the ground, whether it be a UAV, helicopter, aerospace applications, whatever the application happens to be. Getting more processing at the platform so it can be reacted to in real time is really what it's all about. So there's been a lot of things, multi-cores, mini-cores. We need higher bandwidth, we need inter-process communication, so all these things have to play together. Open systems architecture to provide a platform where we can do the processing on the platform. And what are some of the things that bring those challenges? So if you think about synthetic aperture radar, this really comes from the back, like the side looking airborne radar. So we're really trying to synthesize a larger array, if you will. Lots of processing required to do that. If you've got a ground moving target indication, so you've got something's moving on the ground, you've got to process that, try to get all the noise out of the way. You want to focus on your target. What are you trying to track? Persons, vehicles, whatever it happens to be. So loads of processing power, and if we can get that processing power into the vehicle, that really becomes a big advantage for us. And we did this several years ago with a system similar to this. So this is about an 18-slot 6U chassis, somewhat heavy, somewhat large, 2,000 watts, massively powerful in its day at 576 gigaflops. So this is the kind of thing we were doing about 10 years ago with the 6U system, at least 10 years ago. And didn't really have the 3U systems at that time that could do that kind of thing. So a couple of technologies have come along that help enable us to be able to do this now. We've heard a lot about the Xeon D this week. So for a few years now, Intel started really in the laptop space. We've seen system on a chip where you've got maybe an embedded processor with graphics, memory controller, all that, and an SoC. And then more recently, we've seen the Xeon D. So now we've got mini cores up to 16, perhaps. We've got loads of Gen 3 PCI Express, maybe 20 lanes. We've got a couple of 10 gigabit Ethernet controllers. So lots of processing power now in the processor itself. Another really cool enabling technology, a GPGPU, in this case, an Nvidia Maxwell GPGPU. So 640 cores, quite a few cores now. Lots of processing, up to a teraflop, for example, here. Again, Gen 3 PCI Express to move the data. CUDA, this is a compute unified data architecture, so now I'm able to use this thing as a coprocessor, if you will. This is just a little bit about how it looks, the CUDA model. So essentially I've got a CPU connected to many cores, and now this thing's not just about graphics. This thing is really about a pretty massively powerful coprocessor. So if I've got a problem in radar, whether it be SAR or GMTI, are two perfect problems that can be applied to this kind of thing. So I can put all this together, and I've got a way of doing that. So I put it all together, and maybe I do this now in 3U OpenVPX. And what I see, let's see, I guess there's a pointer, yeah. So I've got pairs here. I've got a processor maybe based on a Xeon D. I've got a GPGPU 3U card based on the Nvidia GPGPU. And as you can see, I've got 3 pairs of those. I've got a switch at the very end. And now you can see what I've got. I've got less than a cubic foot of space, a lot lighter, less than 45 pounds, and I really estimated this, I think quite a bit less than 45 pounds, much less than 500 watts. And now what have I done? I got 4.5 teraflops. I got 4,500 gigaflops capable in this smallish 7-slot box, for example, that we put together. So we can see, we can bring all these elements together and we can address these fairly significant processing capabilities with an OpenVPX 3U system. Considerations. This is, like what it's all about. Radar applications are very suitable for combinations of CPUs and GPGPUs. We've heard some about this, just more on this. I mean, we've seen the trends. We're at Gen 3 now, PCI Express, so we're really pushing the boundaries of a VPX connector. We know Gen 4 is coming. We're at 10 gig, whether it be KX4 with 4 pairs, or we've got KR with a single pair. We're really pushing that hard. We've got the need to trend towards 40 gigabit. Optical interconnects have to be considered. What we heard earlier, rugged optical interconnects, they clearly have to be centered. We know what's going to happen. CPU cores are going to keep going up. We talked about 16 core Xeon D. What's going to be next? Maybe 20 cores, maybe more. Nvidia already has the Pascal next generation GPGPU on their roadmap. That's more than 1,000 cores. Loads of processing capability. Of course, what comes along with all that? More thermal densities, more thermal challenges. So I was kind of hoping Ray Alderman was going to be here this week, because this is one of these cases where he may finally be right. I mean, we may truly have a need to move beyond electrical interconnects into optical interconnects as we extend beyond, up to and beyond 40 gigabit Ethernet. Because the processing capability is going to keep going up, the throughput in the system, the challenge, the demands is going to keep trending up. So we're going to have to do things to address that. But clearly 3U is a great way in a swap constrained environment to address the challenges we have today, and it will continue to scale. We'll see more from that as we go forward.